we're getting ready to bake some concrete. Baking concrete. So there's you see the bottom of the pan. It's fully watered down. Alright. It's nice weather out here. There's nothing drying it out magically. Now let me go ahead and make up a little mix. But I'm going to put in this mix, I'm going to put in the bottom of the mix some foam. This little animal here. Nope, not the animal fully. You'll see. So there's our little animal. Water's still in there. It's just foamed in. It's laid in there. We're going to put concrete across this. Of course, this is almost near the top of the surface, so it's exaggerated. Maybe I'll take off a layer, and because we can see the edge there, I'll put the concrete to the top. But it might work better for me at this point because I'm trying to make sure we accelerate this failure in the baking class here. I think I will keep it like that, and we'll only get this much concrete cover there. And in essence, that's what we're going to look at. What we're going to look at is that concrete is placed inside wherever you're placing it. But sometimes you get a high point of stone. Oh, and hey, I'm using this. I'll use stone to prove a point. I just wanted to show you guys the intent of the pathway. So I'm going to use some stone there that is going to be higher than the rest of the pan. We're going to be able to create a crack in a pattern. We'll see. So what you see here is my baking pan. My baking pan has a base. The base has not been tamped, but it's so thin that we're not going to worry about that, right? But basically what I'm showing is your cracks are not random. So basically what I'm showing you is your base is not level. This creates a thin layer of paste and concrete above, and that's where your cracks are coming through, if you can visualize the scale. Now I'm going to put concrete over this, and we're going to bake it at 100 degrees. Question is, which product do I use? This has fiber in it, the quick wall. I got masonry cement, stucco, Portland cement. I got rapid set. Interesting. Rapid set will give me my fastest, if anything, but it's not what we typically use. So I can't use rapid set. We're going to have to go with a made product. Now fiberglass would be cheating. It's going to be stronger, so I'm going to have to go with the masonry cement with some sand. 3 to 1. Maybe I'll do 5 to 1 on the sand, on the masonry. Maybe 5 to 1. I'll determine it by the time I get to it. So I went with 3 to 1. 3 to 1 mix. Try mixing first, and then I'll add water. And there we are with some stone in there. Add a proportion of about probably another one part stone. So we've got a total of 4 parts aggregate to 1 part. Type in Portland cement, masonry cement. Okay, now we did the hokey pokey. We stirred it all up and stirred it all about. Now let's just add it as a typical pour. You can see it looks pretty rich, pretty nice. Typical pour. Let's go ahead and tamp it down. Now, we won't give it any extra treatment. Make a little pie. Let me see if I can get more in there. Let's make a little concrete pie with nothing special, no extra vibration. We'll get obviously some vibration as I carry it up the steps to put it in the oven at 100 degrees. Beautiful temperature today. It might be 70 degrees. I can let this stay out here all night and let it work, but we want to accelerate this a bit. Proof of concept for you guys. We're going to accelerate it with 100-degree oven, which will be, pretty much consistent all the way around, except for the pan will be a little bit hotter. Obviously, the metal around this outside of this pan is going to want to radiate inwards. We already got air bubbles coming up, so that will be a slight factor. But the point is, when I get this upstairs, I won't even know where the stones are anymore. but the stones are still high in this. We're going to get our shrinkage by this accelerated drying consistently, and I predict that it will be above our stones, right? And I don't want this is right now is vibrating on the metal. It's also around that rock, vibrating down around that rock, creating a nice paste on that rock also. Let me go ahead and stop that. Let me go get this in the oven. You guys believe this is a caveat when using this oven. It doesn't appear to go below 100 degrees. I mean 170. I've already added the salt and pepper to this mix, and let's go ahead and place it on the upper rack to try to give us the most even amount of heat around here. I'm going to put a gauge inside here and monitor it. But here we go. Let's cook, little baby. I'll monitor this at 100 degrees, looking at the light. And we'll watch it. I'll even open the oven now and then, simulating, you know, a breeze coming across it every now and then. It's going to be a dry heat, very dry heat in the oven. Not really fair to the real world. Perhaps it is, though, if you're in Arizona. Here we go. I decided to go with the probe after all. In this video, there's the probe, and I'll be monitoring the temperature inside that concrete. Let's get to that point. Also, my intent is to accelerate the process for shrinkage, and the shrinkage being controlled. It should be even. It's in an oven. Or will it not be even because of the stone that's placed in there at a thinner ratio than the rest of the surrounding area? Should create a tension at that point, and the crack should develop. Now we're up to 99 degrees. Let's go ahead and check on the baking. Let's check on the baby. The baby in the oven says, nice. I think I would like to, in this stage of the game, it's 100 degrees, so you can see I keep my hands on it. Obviously 100 degrees won't burn me. It's not enough. We're 98.6, right? So this is just almost a trade-off. The oven, though, is above 100 degrees, but this is 100. Oh, it's setting up. You see my finger there. It's got some set to it. Okay, it's been some time now. Some time over an hour, and I'm going to maximize 115, monitoring it. It's great. It's actually out west. This is 115 would be a solid okay temperature they pour in out there. It's craziness, right? But so this is the accelerated process. Here we go. Okay, guys, the pie is ready. Concrete pie. This is where I kept the temperature gauge at. It's still warm. Now I did not do any finishing on this. You saw it as far as I took it, but she's pretty hard. Well, I put the pie in the window to dry. I put the pie in the window to cool down. I hope nobody comes around and steals it, like a little pie burglar like you do in those movies. We'll find out. Okay, here's my cake. Oh, cake needs a white balance check. Hold on. Okay, here's the cake. As you can see, no cracks are presenting. Let's go ahead and get down here. We're going to let it go kind of close to the floor and then work our way up. Where are you? Okay. So now we got cracks around the outside. Around the outside, right here. Let's drop it again. It's obviously laying flat. Well, let's go again. Okay. Obviously that's landing on this edge and causing the flexural breaks. Aha! But we have a crack across the pad now. Right here. Here's a crack. Right there. I hope you guys can see it. Let me zoom in, I hope. Let me see. Trying to make sure you can see it. Right. There's the pattern of the crack. Let's see if that's where my rocks are. Of course I don't recall where they are at this point. Let's drop it again. Okay. So we clearly see there's a crack, right? Where are you guys? You can clearly see this is the crack. Right here. Let's see if that's where my rock pattern is. So I'm going to turn this cake upside down, and we're going to see if that's the the rocks. Don't know if it's going to come apart like that is, do I? Yeah, I got to clean all this up. But for you guys, it's worth it. So there's the crack. Let's see. Gosh, it didn't let me get it. Okay, so now you're looking at the rest of the high points, but this is the one we're going to focus on. Let's see if I can get that off. No, it's not coming easy. This is the one I want. It's not coming easy, guys. Let me drop it a couple more times. Start if I can see if I can get this to break up more. There we go. It's getting there. Let's drop it again. This is the one I care about. Right here. Let's start digging down in there now. Let's start probing that. So let's probe this. That's that crack that we saw. Making sure you can see what I'm doing here. So we're almost at the bed. There's the bed of the stone I placed. Still there's the bed. Let's go ahead and take this off. Let me zoom in. Zoom in and tilt up for you. You can give me a dustpan, that wouldn't hurt, but I'm going to finish this project. I'm going to finish this project whether it messes the floor up or not. So here we go. Large rock. Large rock is coming out good. These are those large rocks. Remember the cross section with the large rocks? Here's two. I believe that's rough. Well, maybe. Let's see if I can turn this upside down a little bit. There's three. That was the path. That was the edge of it at the bottom there. That was the path of the large rocks we put in. Straighten her out. And I think there's one more right here. Was there just four large ones? I'd have to look at the video again. But now you see where the cracks developed. Of course, we saw a perfectly nice top. But yet when it was loaded, it showed failure at the inconsistent larger rock area. The rest being uniform. So I think the 3/8 stone gives you a stronger concrete than the irregulars. The irregulars are part of your random issue, I think. The irregular rock size, just too damn large. Too damn large for the paste. I've got another video I'm going to show you guys about when you're breaking this up, what the how when it breaks, when it shears, when it comes apart, how it's only the paste that you will not see a split down a rock. I have not found a split down a rock. That you will see the paste has failed. That's going to be more data I'm going to give you. But right now I just want to show you the consistency of the rocks in here. And yes, this took many hours to make, and then I'm destroyed immediately. Yeah, it's uniformly the same, baked out the same. So I'm really happy with this. So I'm going to say it again, but in the video I think, but I'm going to do a voiceover real quickly. So even the 3/8 stone or the different stones, as you add them into your into the mix. If they stack up, and say 3 of them stack up together, well, they start equaling one large stone, which creates a random point of weakness. Multiple stones. So the tamping is really, and the vibrations really can be your you're creating your your weakest points, putting control joints in where you don't want them by your stone stacking. Here we go. So, hope you guys can appreciate that. So if this was the fail here, you would see it never across the stone, but it would create a shear point around the stones in the paste. No matter how much this bonded this concrete is, it doesn't have the bonding force or to crack one of these stones. Stones, stones, stones. So 2 stones together, that equals what? 2 stones together looks like one stone, doesn't it? So when you're vibrating, you get these stones on top of each other, you're creating a weak point. If they start stacking up, weak point. Same thing as this guy in cross section, if you will. So you don't want to migrate your stones. You want them all to be consistent. I'm ending the video. This took me all day to make, off and on. Thanks guys for watching, and please join in. And there you are, for all you guys who worried I didn't clean the floor up. I cleaned that floor up. Even between the cracks. Vacuum cleaned, scrubbed, washed, all done.